Good morning, dear students. Welcome back. I am your physics professor Dr. Nagaraj explaining engineering physics model question paper. This is module number 5. I have already uploaded 4 videos. In this video, I am going to conclude the discussion of model question paper. This is for computer science and engineering branches and also allied branches. Dear students, in the description box I have given the PDF of questions and answers for this question paper. Also I have given some expected questions or important questions selected from all the modules. Okay, so please prepare for all these questions. I hope this much is sufficient for you to get a very good score in the main examinations which are coming, which are at the corner. Okay, as usual I start with the question number 9A. Discuss timing in linear motion, uniform motion, slow in and slow out. This is about physics of animation. Dear students, I have made several videos on physics of animation. I hope you have already watched those videos. Just for the sake of revision, you watch them once again. Here is the answer. First you define what is linear motion. Any object which is moving in a straight line is called as linear motion, and during the motion the body may travel with uniform or non-uniform. That motion may be uniform or it may be non-uniform. When it is called uniform, only when the acceleration is 0. That means velocity is constant. When it is non-uniform, means when the velocity is variable. That means there is acceleration, constant acceleration, of course. Okay, for acceleration force must act on the body. If there is no acceleration, no question of force. That is according to Newton's second law, F is equal to ma. When a body is moving with constant acceleration, there must be rate of change of momentum, and that is definitely because of the applied force, that is Newton's second law. Anyway, after explaining what is linear motion, what are the different types in linear motion, that is uniform and non-uniform motion, proceed further. See, in uniform motion, as I told just now, net force acting on the body is 0, so acceleration is 0, velocity is constant. So the body travels equal distance in equal intervals of time. So for such type of motion, timing is very simple, framing is also very simple, because equal intervals of time, equal distance covered. So distance traveled is same, spacing will be same, timing is also same. So that is for uniform motion. Acceleration is 0, velocity is constant. But normally in our day-to-day life, motion is not at all uniform. There are accelerations. Accelerated motions we encounter, whether it is your walking or running or oscillation of the pendulum or jumping or speeding car slowing down, all these motions are associated with acceleration only. In such type of cases, we divide the whole event into different parts. For small parts, acceleration is assumed to be constant. Actually, while walking also our acceleration is not constant, but for a small interval of time, acceleration is assumed to be constant. By assuming acceleration constant for a small interval of time, we divide it into 2 parts, namely slow out and slow in. For example, car. So from the initial point it gets accelerated. As it gets accelerated, spacing keeps on increasing. This is slow out process. And when the car is ready to stop, it gets retarded or decelerated. Now the body is slowly reducing its speed, and it is called slow in. Slow out is entry point, slow in is exit point. Slow in is also called as ease out. Slow in is called ease in. Ease out, ease in. Okay, so in ease out and ease in, also slow out, slow in, framing is not uniform. Initially we will have more number of frames nearby, and gradually framings increases, gap increases, number of frames decreases, and again there will be increase in the frame. ಅಂದರೆ ಬಿಗಿನಿಂಗಲ್ಲಿ ಜಾಸ್ತಿ ಫ್ರೇಮ್ಸ್ ಅನ್ನು ಬರಿತೀವಿ, ಮಧ್ಯದಲ್ಲಿ ಕಡಿಮೆ ಫ್ರೇಮ್ಸ್ ಅನ್ನು ಬರಿತೀವಿ, ಮತ್ತು ಇನ್ನೇನು ಪ್ರೋಗ್ರಾಮ್ ಎಂಡ್ ಆಗುತ್ತೆ, ಮೂವ್ಮೆಂಟ್ ಎಂಡ್ ಆಗುತ್ತೆ, ಕಾರ್ ಈಸ್ ಸ್ಟಾಪಿಂಗ್ ಅಥವಾ ಪೆಂಡ್ಯುಲಮ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ದಿಸ್ ಸೈಡ್ ಅಂತ ಟೈಮಲ್ಲಿ ವಿ ಅಗೇನ್ ರೈಟ್ ಮೋರ್ ನಂಬರ್ ಆಫ್ ಫ್ರೇಮ್ಸ್. ಲುಕ್ ಅಟ್ ದೀಸ್ ಡಯಾಗ್ರಾಮ್ಸ್. Look at these diagrams. In the first case, this is equal spacing, equal number of frames, equal timing. This is the case of uniform motion, where this is a case of acceleration 0, uniform motion. Okay, but this is not a uniform motion where acceleration is not 0. This initial point we have more number of frames. This is slow out. When you come to the middle part, the spacing is more, where initially spacing is less, frames are more. and you know the meaning of frame, I need not have to explain it again and again. Frame is nothing but one diagram is one frame, that's all. Okay, so that way pendulum, there are more diagrams in the initial case, again more diagrams in the final case, in between we have less diagrams, okay, less circles are there. So this is slow in, this is slow out. This is what I have explained here. Slow out or ease out is a process in which body is speeding up. To create slow out, we need to place more number of frames close together, whereas slow in is a process in which body is preparing to stop. To create slow in, we need to again place frames closer together at the end of the animation. So this is about the timing in case of linear motion and the slow in, slow out. Next question, distinguish between descriptive and inferential statistics. This is about statistical physics. Even on statistical physics also I have made videos. Please watch. There I have given detailed explanation. Since this is only model question paper discussion, I cannot give detailed explanation because it consumes a lot of time. I just give you what answer you have to write for this particular question. Here is the answer. The process of organizing and describing, that is more important. ಅದಕ್ಕೆ ಅದನ್ನ descriptive ಅಂತ ಕರೆಯೋದು. Organizing and describing the known data using charts, bars, graphs, etc. is known as descriptive statistics. Like in your section, how many students are there? 70 students are there. How many of them got first class? How many second class? How many distinction? How many failed? All these things you arrange and represent it either by bar chart or by pie chart or just only numbers. That means it is only explaining descriptive. You are explaining, you are describing the result. Statistics, that is called descriptive. And this enables researchers or observers to present the data in a more meaningful way so that we can easily make out, it will create some impression. ಈಗ ಯಾವುದೋ ಒಂದು ಸೆಕ್ಷನ್ ಅಲ್ಲಿ 70 ಮೆಂಬರ್ಸ್ ಅಲ್ಲಿ 65 ಮೆಂಬರ್ಸ್ ಡಿಸ್ಟಿಂಕ್ಷನ್, 4 members first class, 1 second class, no fail. What impression it gives? This is a very good section. All students are very good. Like that type of impression we can create by giving the data in a descriptive manner with the help of bar chart or graphs or pie charts, etc. Okay. Next is inferential. See, one section from one college, but in that college there are, let us say, 20 sections. So from 20 sections, what is the data? If I can analyze all the 20 sections and put it in descriptive manner, that also will give impression. But assume that 20 section data is huge. Like for example, height, normal height of a person, human beings normal height I want to find out. How to find? Easiest way is, actually accurate way is measure height of all the human beings on this earth, divide it by total number, you will get the average height. Okay, like that. That is impossible. Like that. Similarly, I want to know how much students are, or what is the impression about this college, or what is the impression about this school, whether students are performing, all the students are performing well or not. I want to draw some conclusion, inference and the conclusion. So how to draw the conclusion? For that again I have to analyze the data. In the college, let us say there are 5,000 students. I cannot analyze 5,000, full 5,000. It is a lengthy, not risky. It is lengthy. Then I will select the data. Okay, from first year few students, second year few students, third year few students, fourth year few students. I take the samples. So select madi. Afterwards you arrange the data. From the data, let us say first semester 60% first class, second semester again 62% first class, third semester 71% first class, again fourth semester 65% first class. See, all the semesters first class is around 60-65 only. Therefore, what inference I can draw, what conclusion I can draw? So in this college, 65% of the students are above 60%, means they are very good, first class. Like that, suppose if I get 10% or 12% or 13% distinction from all 8 semesters, 1, 2, 3, 4, 5, 6, 7, 8 semesters, then what I can say, in this college 10 to 12% of the students are supreme, means they are above average, they are distinct, they can bring ranks to the college. ಈ ತರದ ಕನ್ಕ್ಲೂಷನ್ಸ್ ಅನ್ನು ನಾನು ಡ್ರಾ ಮಾಡಬಹುದು based on the statistics. That type of statistics is known as inferential statistics. statistics. So that whatever I explained here, it is inwardings. The process of making predictions or conclusions and generalizations about the data is known as inferential statistics. Describe ಮಾಡೋದಕ್ಕೆ ಯೂಸ್ ಮಾಡೋದು descriptive statistics. Conclusion ಅಂದರೆ inference ಅನ್ನು ಬರೆಯೋದಕ್ಕೆ ಯೂಸ್ ಮಾಡೋದು inferential statistics. When the data is very large, ಅದೇ ಹೇಳಿದ್ನಲ್ಲ 5000 students is very large, it is difficult to use it. In such cases, certain samples are taken. I told you, select few students from first year, second year, third year, sampling, and then arrive at a conclusion. So while choosing the samples, you have to be very careful. Only first year ತಗೊಂಡ್ರೆ ಪ್ರಯೋಜನ ಇಲ್ಲ. Take some 10 students from first year, 10 students from second year, 20 students from third year, 10 students from fourth year. Like that you have to make the sampling. This is about descriptive and inferential statistics. Okay, now illustrate odd rule and odd rule multiplier. This is very important question. See, in animation we use this odd rule to find the distances. The rule goes like this: distance travelled between two successive frames is obtained by multiplying the base distance by odd numbers like 1, 3, 5, 7, etc. During the accelerated motion. During acceleration, you multiply the base distance. Base distance andre eno? It is the least distance between two positions, two frames, smallest distance between two frames, and that base distance you multiply by 1, 3, 5, 7 if the body is accelerating. If the body is decelerating, multiply by 7, 5, 3, 1, ulta. But it is once again odd number only. 1, 3, 5, 7 during slow out process, 7, 5, 3, 1 it is during slow in process. This is odd rule. This odd rule is so useful, it is very helpful in finding the distance between the frames, distance between any two frames, distance between first and any other frame. For finding the distance between any two frames, for finding the distance between first one and any other one, we use a rule called odd rule multiplier. That odd rule multiplier goes like this. The process of calculating the distance from first frame to current frame, first frame, current frame may be any one, maybe fourth one, maybe 10th one, maybe 100th one. From here to there, what is the distance? Adanu kandidilikke we use this odd rule multiplier. It is almost similar for slow out and slow in process. Whatever I explained for slow out, its opposite is applicable to slow in. I have taken one example. Here one object is speeding up. Initially the gap was very small, so with the time the spacing is increasing. That body is travelling from first frame to fifth frame, a total distance of 2 meter. Now I want to know from F1 to F2, F2 to F3, F3 to F4, F4 to F5. Or I want to know from F1 to F4 or F1 to F3, F1 to F5. How? With the help of odd rule multiplier. To find the base distance, there is a formula. You have to remember this formula. It is nothing but total distance by last frame minus 1 whole square. Here total distance is 2, last frame is 5 minus 1 whole square. So 2 by 5 minus 1 4 square, that is 4 square means 16. 2 by 16 is 0.125. That is the gap between F1 and F2. Now you find out distance between F1 and F2. F1 and F2 is 1 into base distance. This is what odd rule is. 2 and 3, 3 into base distance, 5 into base distance, 7 into base distance. So you get these numbers. Now you add all these numbers, you get the total distance. This is odd rule and odd rule multiplier. Dear student, this is one of the important question. Please practice this. Okay, now comes what is called describe jumping parts. ನೋಡಿ, ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಜಂಪ್ ಆಗಬೇಕಾದ್ರೆ ಅಥವಾ ಒಬ್ಬ ಮನುಷ್ಯ ಜಂಪ್ ಆಗಬೇಕಾದ್ರೆ ಅಥವಾ ಒಬ್ಬ ಅಥ್ಲೆಟ್ ಜಂಪ್ ಆಗಬೇಕಾದ್ರೆ ದ ಹೋಲ್ ಜಂಪಿಂಗ್ ಮೆಕ್ಯಾನಿಸಮ್ ವಿ ಡಿವೈಡ್ ಇಂಟು 4 parts. Number 1, crouch position. Here the person is getting ready to jump. Okay, he will shrink the body, is ready to take off. Okay, next take off, he will push the ground and rises up, and then once he rises up he will be in air, that is in air position, and finally he is going to land. So these are the 4 parts: crouch, take off, in air, landing. I have given a lengthy explanation over there, but I tell you, if you can explain in your own words, this is sufficient. 1 position, 1 mark. Little bit explanation, 1 mark. Like 1 position ge 2 mark andre 4 position 8 marks. Crouch is the initial position where the body of the jumping or athlete is shrunk. Center of gravity is concentrated at the center of the body as shown in figure. Next, take off. she or he or athlete is getting ready to take off. ಈ ತರ ಬರ್ಕೊಂಡು ಹೋಗಿ. ಈ ಪ್ರೋಸೆಸ್ ಅಲ್ಲಿ we define some parameters. Time taken to jump is called jump time. Time taken to land is called landing time. ಅಥವಾ jump time taken to go from crouch to this particular position to take off, that is called take off time, and that is push height, right? ಆಮೇಲೆ landing height, all the details are given there, just go through it. Okay, ಇಲ್ಲಿ ಏನಿದೆ ಅದನ್ನ ನೋಡ್ಕೊಂಡ್ಬಿಟ್ಟು ನೀವು ಸಮ್ಮರೈಸ್ ಮಾಡಿ. ಬಟ್ ವಾಟ್ ಐ ಸಜೆಸ್ಟ್, you better write the names. Crouch, worst case ಅಲ್ಲಿ you write crouch, take off, in air landing, and this diagram. Okay, that will fetch you at least 50% of the marks. Okay, well, I move on to the next question. Discuss the salient features of normal distribution curve using bell curve. Normal distribution means if you take this as center, this side and that side equal distribution. Like for example, in your section 70 students, among 70 100 marks, 100 marks better 90 marks ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. Some are 90, 80, okay, 70, 65. If you take 50 as the middle one, some of them might have scored 40, 30, 20, fail also. Okay, so this is called uniform distribution. Above the center, the data is distributed equally on both the sides. Okay, such type of distribution is called normal distribution, and the normal distribution is represented by this type of curve. Because it looks like a bell, it is called as a bell shaped curve. Okay, from the bell shaped curve we can calculate the basic parameters like mean, median, mode. Okay, the peak represents that, and some examples we can give. Height of the people, ಈಗ ನೋಡಿ ನಾವು ಎಷ್ಟೋ ಜನ ನೋಡ್ತೀವಿ, ಕೆಲವು 6 feet ಇರ್ತಾರೆ, ಕೆಲವರು 6.2 ಇರ್ತಾರೆ, 4 ಇರ್ತಾರೆ, 4.5, 4 is very less ಬಿಡಿ. 4.5 to 6.2 ಅಂತ ತಗೊಂಡಾಗ you can keep 5.5 as middle, 5.5 this side, that side, 5.5 this side ಅಂದ್ರೆ up to 4.5, 6.5 that side ಅಂದ್ರೆ up to 6.5, but 6.2 is okay. So height of the people is normal distribution. Like that I have given some other examples like blood pressure. Blood pressure of the body keeps on varying. The daytime 120 ಇರುತ್ತೆ, sometimes it comes down to 110, sometimes it goes to 130, 140, like that. So that is also uniform distribution. Suppose 120 is normal, it is going towards higher side only. Tomorrow it is 130, day after tomorrow 140, ಆಮೇಲೆ 150, 160 ಆಯಿತು ಅಂದರೆ high blood pressure ಅಂತ, ಅಂದರೆ you have blood BP problem. Suppose if it is going this side, today 120, tomorrow 110, day after tomorrow 100, 70, 80, low BP, ಆ ಥರ ಅಲ್ಲ. So normal human being blood pressure, that side, this side, it should be distributed uniformly. Okay, like that. Well, coming to the last one, number of particles emitted per second by a random radioactive decay has a Poisson's distribution with lambda equals 4. In Poisson's distribution, two parameters are very important, lambda and then x value. Find out the probability P. See, P, lambda and K are related. K ಅಥವಾ x are related by this formula. P of x is equal to K. Remember, x is a variable and it takes values from 0 to any value. That is the happening. I have given beautiful examples in my video. Please watch this. ಈಗ ಒಂದು ಕೋಳಿ ಇದೆ, ಮಾರ್ನಿಂಗ್ early morning you leave it, and then by the end of the day it will lay definitely one egg. Okay, now the question, what is the probability of that hen laying one egg in one day? 100%. But my question, morning 5 o'clock to 6 o'clock, what is the probability? I don't know. It may lay the egg, it may not lay the egg. ಬೆಳಿಗ್ಗೆ ಫಸ್ಟ್ 1 hour ಅಲ್ಲಿ 5 ಗಂಟೆಯಿಂದ 6 ಗಂಟೆಗೆ ಕೋಳಿ ಮೊಟ್ಟೆ ಇಡ್ತಾ, I don't know. ಅಥವಾ 5 to 7 ಮೊಟ್ಟೆ ಇಡ್ತಾ, I don't know. Okay, 0 ಇರ್ಬೋದು, 100% ಇರ್ಬೋದು, ಆ ಥರ. Instead of one hen you have 100 hens. 100 hens ಅಂದರೆ one day ಮುಗಿಯೋಷ್ಟೊತ್ತಿಗೆ there must be 100 eggs. Out of 100 eggs, now I want to know morning 5 to 6 whether 10 eggs are available. We don't know. Okay, we don't know. That is x. That is x is equal to 10. Go and check. 10 hens might have laid the eggs already. Then your purpose is served. What is the probability of x becoming 0? ಅಂದರೆ ಒಂದು ಕೋಳಿನೂ ಮೊಟ್ಟೆ ಇಟ್ಟಿಲ್ಲ ಅಂದರೆ ಮಾರ್ನಿಂಗು 8 o'clock ಅಲ್ಲೋ 10 o'clock ಅಲ್ಲೋ, that is variable. Like that, such type of distributions we calculate with the help of Poisson's distribution. I have given beautiful example, even not only this hen, even the nuclear the proton decay example, everything I have given in the video. If you want more information you can watch. Here I have solved the problem. P of x is equal to k is equal to, this is the formula. Substitute for k I have taken it as 0, lambda is constant, average value, If I simplify, I get the answer as 1.8%. Next, if I take a is equal to 1 and lambda equal to 4 in this formula, I get the answer as 0.073, it is 7.3%. Well, dear students, these are the numerical problems on statistical distribution. In my previous video, I have discussed in detail about Monte Carlo and how to find a pi value. That is also very important. So, ಈಗ ನಾನು ಹೇಳೋದಿಷ್ಟೇ, if you refer my videos, first paper and second paper full, and if you solve those important questions which I have given, I think it is sufficient. You can easily face with confidence the forthcoming examination. So, dear students, please like my videos, share my videos, stay with me. Even if you go to higher semester, I will try to help you by doing videos on your computer science subject related, or I get some professionals who are equally good in teaching, okay, and I will try to make videos on computer science related topics. I hope you will support me, you stay with me, okay. Thank you for your feedback and constant support, okay. Thank you once again.